Our next lesson, we're going to take a look at the difference between relations and functions. A relation is any sort of relationship between 2 points. An equation, a graph, they all count as a relation. A function is a special type of relation where each input or x value has only one y value. Another way to tell if a graph is a function is by using the vertical line test. Based on my previous experience, students really tend to understand the vertical line test if any vertical line on the graph touches the graph more than once. It is not a function. And finally, we'll take a look at domain and range. And these two concepts tend to be challenging, so make sure you're paying attention and asking questions on these two concepts. Domain is any x value or input that you can put into the function, and the range is what you get out of the function, or the y values. We're going to start off with a visual representation of a function, and hopefully you'll understand the concept of domain and range a little bit better. So this is a visual representation of a function. I call it the function machine. What you put into the function that gets dropped into the top, that's the domain. Anything that's legal to put into the function. So we've already seen equations or expressions that have a denominator with a variable, and there are domain restrictions. So that would impact what you can put into the function. And then off to the right, we see the orange triangle coming out. Those values are the range, whatever you get out of the function. So certain functions, once you drop values into them, they change the values so that you get a special range. In addition, we're going to start using what's called function notation. And it's this concept of f of x. That replaces the y in any equation. What it allows us to do is see exactly what we're putting into the function, the x value. And then when we evaluate that, the f of x represents what you get out of the function. Differentiating between relations and functions. Remember, each x value can only be paired with one y value to make it a function. So what we do when we look through this table is we check to see if any x values repeat, or any x values paired with more than one y value. In this case, the answer is no. We do see a y value repeating, but that's okay in a function. So again, the answer is yes, because none of those x values repeat. For part B, we have a graph, so we'll use our vertical line test. If we look at the y-axis as our first vertical line, so far so good. It only touches the graph in one location. But as soon as we move to the right at all, now we touch the graph more than once. So it fails the vertical line test, so it is not a function. Next, we'll take a look and see if we can determine if an equation is a function. What you do to determine if an equation is a function is you solve for y. If you get y alone and you don't have anything like a plus or minus sign on your x, then it's a function. For our first equation, we already have y alone. There's no plus or minus sign on our x, so yes, it's a function. Our second equation, the y is in absolute values. To solve for y, we would start by subtracting 8 from both sides. And remember, when you solve an absolute value equation, you set up two different equations. One, where it equals whatever expression you got. The other one, where it equals the opposite of the expression. So here we have y with two different equations, which means this is not a function. Now we're going to get into evaluating with function notation. A lot of students tend to struggle with this concept of function notation. So what's really important to remember is that whatever is sitting inside those parentheses is what you are inputting into the function in place of x. So we'll start off with a more basic one where we're replacing x with a number. We're also going to replace x with that value on the other side of the equal sign as well. It's simply substitution. Wherever we saw an x, we're going to change it into a 2 in this case. Evaluating, 3 times 2 is 6, plus 6 is 12. So we could write f of 2 equals 12. As an ordered pair, it would be our x value was 2, and our output, or y value, was 12. Next, we're going to do the same thing for f of w. Everywhere we saw an x on either side of the equal sign, we're going to replace it with a w. So f of w would look like 3w plus 6 instead of 3x plus 6. Next, we're replacing every x with x plus 2. So on both sides of the equal sign, everywhere there was an x, we're changing it to an x plus 2. Simplifying this, we'll distribute the 3 and combine our like terms. So f of x plus 2 equals 3x plus 12. Taking a look at that one more time, evaluating our function at the value of 2, we'll replace every x with a 2. Absolute value of 2 is 2, divided by 2 is 1. So f of 2 equals 1. Since these are both numbers as an ordered pair, that would be 2 was our input or part of our domain, and 1 was the output or the range. Next, we'll evaluate for f of negative 2. Everywhere there was an x, we'll replace it with a negative 2. In the numerator, that absolute value makes the negative 2 positive. 2 divided by negative 2 is a negative 1. So this time f of negative 2 equals negative 1, or our input or domain was negative 2. Our output range y value was negative 1. Finally, we had f of x plus 1. Everywhere there was an x, we'll replace it with an x plus 1. This can't be simplified as those values in the numerator are in absolute values, and that's a grouping symbol. The final piece to our lesson today is domain and range. Remember, domain is the input or the x values in your function or relation. In this case, our x values are 0, 1, and 2. So that is the domain of this function. None of those x values repeated, so it is a function. The range would be the y values or the output. In this case, 1, 3, and 5 were our y values. And your 2U try questions.